Software testing, variations of mutation analysis, presented by Varuniam. Variation of mutation analysis. What is mutation analysis? Mutation analysis is a technique used in software testing to evaluate the quality and effectiveness of test cases by introducing artificial faults known as mutations into a program's code. The process involves running the modified code with a test suite and checking if the test can detect the introduced fault. Here is the diagram how it works. Original program, mutant program, and the output. Compare the results of both the program and it generates the output. Variation on mutation analysis. While the basic principle of mutation analysis remains the same, there are several variation and extension of this technique that have been developed over the time. Here are few notable variation on mutation analysis. Traditional mutation analysis, higher order mutation analysis, equivalent mutate analysis, selective mutation analysis, coupling mutation analysis, multi-objective mutation analysis. Variation of mutation analysis. Traditional mutation analysis. This is the original form of mutation analysis where simple syntactic changes are made to the program's code, such as changing an operator or replacing a variable with the constant. The test suite is executed against the mutated code, and if the test case failed to detect the mutation, it is considered as inadequate. This shows the diagram. Higher order mutation analysis. In this variation, mutations are not limited to simple syntactic changes but can involve more complex transformation, such as replacing expression or statement with the equivalent but different ones. The goal is to create more challenging mutants that can expose subtle errors in the test suite. Equivalent mutation analysis. In traditional mutation analysis, mutants that are functionally equivalent to the original program are often generated. These mutants may not be useful for evaluating the test suites effectively. Equivalent mutant analysis focuses on identifying and figuring out mutants that are semantically equivalent to the original program, thus reducing the number of redundant mutants. Selective mutation analysis. Instead of mutating the entire program, selective mutation analysis targets specific portions of the code that are deemed critical or more likely to contain faults. By focusing on selected code regions, this approach reduces the computational cost of mutation analysis, while still provide valuable insights into effectiveness of the test suite. Coupling mutation analysis. This variation extends mutation analysis to consider the interaction and dependencies between different components or modules of a software system. Mutations are applied not only to the individual component but also to their interactions, allow for the detection of fault that arises from the coupling of different modules. Multi-objective mutation analysis. Typically, the goal of the mutation analysis is to evaluate the adequacy of test suite based on fault detection capabilities. Multi-objective mutation analysis take a broader perspective and consider multiple objects